This is Euclid Book 8, proposition number 4. I'm going to show you this illustration. Go ahead and pause the video. Okay. Now that we got that out of the way, let's go through this, shall we? Given as many ratios as we please in least numbers, to find the numbers in continued proportion which are the least in a given ratio. Let the given ratios in least numbers be that of A to B, that of C to D, and that of E to F. Okay. So what we're going to say is, as A is to B, so is C is to D, so is E is to F. That's what we're going to say. Okay. Let G, the least number measured by BC, be taken. Okay. So, G, okay, can be measured by both B and C. Okay, G can be measured by B and C. Okay, and there are no numbers lower than B and C that can measure G. Okay. And this is by Euclid Book 7, proposition number 34. And as many times as B measures G, so many times also let A measure H. So let's say that let's say B was 2 and G was 6. Okay, so B would measure G 3 times. Okay, so we could say that A was 3 and H was 9, hypothetically speaking, and we can say that A measures H 3 times. Okay, so let me say that again. As many times as B measures G, so A measures H. Okay. Doesn't look like that from the illustration, but that's the way it is. And as many times as C measures G, okay, so many times let D measure K. As many times as C measures G, let D measure K. Okay. I've already illustrated that point. Now, E either measures or does not measure K. First, let E measure K. And as many times as E measures K, so many times let F measure L. So as many times as E measures K, F here will measure L. Okay. Now, since A measures H the same number of times as B measures G, therefore also as A is to B, so is H to G. This is by Euclid Book 7, definition number 20, and Euclid Book 7, proposition number 13. So let's go through this. So as A is to B, so is H is to G. Okay? Those are ratios. For the same reason also, as C is to D, so is G to K. As C is to D, so is G is to K. And further, as E is to F, so is K is to L. Okay? So as E is to F, so is K is to L. They're in the same ratio. Getting pretty interesting, huh? Therefore, H, G, K, and L are in continuously... Therefore, H, G, K, and L are continuously proportional in the ratio of A to B, in the ratio of C to D, and the ratio of E to F. Okay. Whew. I say next that they are also the least that have this property. For if H, G, K, and L are not the least number continuously proportional in the ratios of A to B, of C to D, and of E to F, then let them be N, O, M, and P. Then since as A is to B, so is N to O. At this point we're going to say as A is to B, then N is to O. While A and B are least. And the least numbers measures those which have the same ratio, the same number of times, the greater, and the less, that is, the antecedent to the antecedent, and the consequent to the consequent. Therefore, B measures O. Now we're going to say that B is going to be able to measure O. So far, so good. For the same reason, C also measures O. Therefore, B and C both measure O. Therefore, the least number measured by B and C will also measure O, which is by Euclid Book 7, proposition number 35. But G is the least number measured by B and C. Therefore, G measures O, which happens to be the greater to the less, which of course is impossible. Therefore, there will be no numbers less than H, G, K, and L, which are continuously in the ratio of A to B, of C to D, and to E to F. And that concludes the first half. Oh wait, the first half? Yes, that concludes the first half of Euclid Book 8, proposition number 4. I will tell you more in my next video, so stay tuned.